Welcome to Pre-Calculus. I'm Mr. Bishop, and this is the first day of notes. This is 1.1 day 1. We're going to be talking about functions. Actual definition of a function, and that is a rule that takes certain numbers as inputs. A rule that takes certain numbers as inputs and assigns them exactly one output number. So functions, not a new idea. You definitely dealt with them in Algebra 2. Let's talk about the phrasing a little bit. So one way we could say, and I'm going to color code this too, is we could say the output is a function of the input. And you're probably used to saying x's and y's, but one way we could phrase it, the output, which would be the y value, is a function of the input, which is typically the x value. You should be used to plugging things in or substituting things into functions and then getting an answer out. Okay, now I'm going to use quotation marks so we don't have to rewrite all this stuff and keep repeating ourselves, but we could also say y is a function of x. So the output is a function of the input, or we could say y is a function of x. Okay, another way to say it, and I think you're used to switching y with f of x. We could say just that. F of x is a function of x. So if you remember back to Algebra 2, y and f of x, those two things are interchangeable. Those are the dependent variables. We call that the dependent variable. It depends on this thing. Depends on what we plugged in as x. So x is our independent variable. So we could say it just like that. Different way to phrase it. The dependent variable is a function of the independent variable. Okay, so we got the definition down. We know how to phrase these things. Let's move to the first example here. So example 1, I'm going to give you a function f of x. So the function f of x equals 2x plus 1. And we're going to look at it 3 different ways. We're going to start with looking at a table of values. So we got to know how to read the inputs and outputs from a table. So let's start by making an easy, some people call it a t-table. Then we'll have the x and the f of x. So we got our inputs, those are the x's, those are the things we're going to plug in. Then our outputs, the f of x. And let's pick some really easy number for the inputs. How about 0 through 3? So 0, 1, 2, and 3 for the x's. Those are our inputs. And then what do we get for the outputs? Those we have to do a little math for. So if we substitute 0 in for x, we just get 1. 2 times 0, that goes away, we get 1. You plug in 1, that should be pretty easy. 2 times 1 is 2, plus 1, you get 3. You plug in 2 for x, you get 5. 2 times 2 is 4, plus 1, there you go. And if you plug in 3, you should get 7. Pretty straightforward. You're used to plugging things in for x and getting an answer. I could have just as easily written y here, but we already talked about y and f of x being interchangeable. So keep in mind, when you're in pre-calculus, we typically use function notation. Instead of xy, we'll use x, f of x. Okay, so we can look at this function from a table perspective. We can also look at it graphically. So let's make some really basic axes here. Got an x-axis down here, got a y-axis up here. 0 in the middle for both of them. Looks like it's just quadrant 1 right now. So you got some axes. How do you go about graphing this function? Well, the important thing to note, if this was x and y, right, these are just points on the graph. 0, 1, 1, 3, 2, 5. So we can just use these to make our graph of the function. We've already got points to graph. So I need to make some tick marks here on my axes. Let's go 1 to 7 on the x-axis. And how about the same thing on the y-axis here, 1 to 7. And then we're going to start with our points. So x, f of x, just like x, y points. So 0, 1 is a point. Put that there. 1, 3. 2537. There's the points on our function. If we connect it, it makes a line. You should recognize that as being a linear equation. The slope will be 2, the y-intercept will be 1. There you go. We can look at the function graphically that way. So we look at it through a table perspective. We look at it graphically. The third way we're going to look at it is just through words, through the phrasing that we talked about earlier. Words, quotation marks. Think about it, how we're going to phrase it. So a function is really a rule. So what is the rule? When we plug in an x value, what happens to it? What's the rule that it has to follow? Okay, so for this function, the rule is for each input, right, for each x value that we plug in, for each input, what do you have to do to it? Well, what does the math say you would do here? If you had to describe this to me, you would say no matter what you plug in for x, for each input, you have to multiply it by 2 first, if you know order of operations, and then you add 1. So notice I underlined that in red. That's important because you're explicitly stating what the order of operations would be. Multiply by 2 and then add 1. So we're describing the rule here in words. So now I've got 3 ways to look at this function. Let's go ahead and take a look at example 2. So I'm actually going to give you a scenario, a sentence, a description of a function. So let's start with heart rate R, and I color code R is red. Heart rate R is a function of exercise E. So those are our 2 variables. Heart rate R is a function of exercise E. And you may or may not be able to guess what I'm going to ask you to do on this one. I gave you the description in words. So I want to know, can you write this in function notation? So like that y equals f of x thing. So think back to what we already know. We know the output is a function of the input. So if we read it in that way, we know R, the output, is a function of the input. That's how we phrase that. So if you think about that way, when we first started out, you can start to line up where the x's and y's would go, or where the r and the e would go, or the function like the f in parentheses itself. So the output is a function of the input. Okay? Is would be like our equal sign, right? So r equals a function, that's the f, right? F of exercise. So you get like parentheses e. So we have r equals f of e. So look at how we line that up. We read it from left to right here. Heart rate, R, is a function, so is the equal sign. R equals f of e. There it is. That's our function written in function notation. And this should make sense just logically, right? How much you exercise, plug that in. That'll tell you what your heart rate is. If you're exercising a bunch, if you're doing a lot of exercise, your heart rate's probably going up. If you're not doing very much exercise, your heart rate's probably not so high. So in this case, what's the independent variable, the input? Definitely E, exercise. Then the output, the dependent variable, that's R, the heart rate. So we don't have a formula, a specific formula for this function, but we could still line up some axes on a graph because we know which one's independent and which one's dependent. So we know which one would go on the x-axis and which one would go on the y-axis. So let's start with just a couple axes here. So the horizontal axis here, that's where x typically goes. That's where our independent variable goes. So in this case, that would be exercise, E. And if we give that some units, let's say that's minutes that you exercise. And the independent variable, the dependent variable, heart rate, is going to depend on how much exercise you've done. So heart rate goes on the y-axis here, the vertical axis, and let's measure it in beats per minute. Now, are there other factors like the intensity? Yes, of course. But in general, we can say you're exercising, your heart rate's going up. Does the graph look like this exactly? I don't know. I'm not a doctor. I don't know for sure. But we know in general, probably you keep exercising, your heart rate rises. So that's really a rough sketch. Again, I didn't have an exact formula to graph. I just know that's probably a general trend that looks like that. And I can for sure label the axes as far as the independent variable would go down here, like where the x-axis is, and the dependent variable would go on the y-axis. All right, example 3. We only have 4 examples in these notes. Here's example 3. So the number of gallons of paint, that's going to be G. The number of gallons of paint, G, needed to paint a house depends on, you could probably guess, the size of the house, and that's going to be S, the size of the house. So the number of gallons, G, of paint needed to paint a house depends on the size of the house. So if I ask you, how many gallons of paint am I going to need to paint a house? Your question, the next natural question would probably be, how much square footage does a single gallon cover? So I'm going to tell you, a gallon of paint covers 250 square feet for this example. I can't say for all paints for sure. So you've got a description here, little word problem. We need to come up with a couple things. First of all, what's the independent variable? What's the dependent variable? Well, I think independent should be S, the size of the house. Because the paint that we buy, the paint that we need, is going to depend on the size of the house. So the dependent variable, that would be G, that's the paint. The amount of paint we need is going to depend on the size of the house. It's not like you go out and buy a bunch of paint and be like, oh, I got a lot of paint, I better buy a big house. It doesn't work that way. The house size, the square footage that you need to paint, that's the independent variable. So the first thing we're going to do is try to express this using function notation, like that y equals f of x stuff, except we don't have x and y here. We have s and g. So if s is our independent variable, remember before that was x, if that's our independent variable, that's the thing that we're plugging in. So instead of f of x, we have f of s. We're plugging in the independent variable, and our output, in this case, would be g, the dependent variable. So in function notation, f of s equals g. Or if you want to look at it the way we wrote it before, you could say g is a function of s. So the output, g, the dependent variable, is a function of s, the independent variable. Notice just the equal sign in the middle. You can write it either way. But in this case, we can actually kind of write a formula because we know something special about that variable g. It says a gallon of paint covers 250 square feet. So how much paint we're going to need if a single gallon covers 250 square feet, we can take the size of the house, S, the square footage, and just divide it by 250. So G is actually just equal to S over 250. So if you're painting something that's 1,000 square feet, right, 1,000 divided by 250, you would need 4 gallons of paint. Okay, so this is function notation. This is nice, but this is really just very general. It's got our 2 variables, but now give me a formula that I could graph or plug into. So if G is just S over 250, I'm going to go ahead and erase this one. Let's go ahead and plug that in right here. G is just S over 250. So we can replace that. We can replace G with its actual value here. So our formula, f of s equals S over 250. So if you tell me the square footage of the house, I can plug it into this formula, plug it in for S, and my answer, again, if it's 1,000, my answer would be 4. My answer is the number of gallons of paint I'm going to need. So we've got a formula for our function. Let's display it in a table. And the nice part about this, we're plugging in values for S, and our outputs, f of s, that's our gallons of paint. The independent variable s, we get to pick whatever we want to plug in. So let's pick some easy values that are going to work nice mathematically in this equation. How about if we have 250 square feet to paint? Let's plug in 250 for s. Well, 250 over 250, that's 1 gallon of paint. What's the next simple, easy value? What if we have 500 square feet to paint? Well, plug in 500 for S, you should only need 2 gallons of paint. How about 4,000 square feet to paint? Well, if 1,000 got me 4 gallons, 4,000 should get me 16 gallons. So if you plug in 4,000 for S, divide by 250, 16 gallons of paint. And then let's graph some axes. We're not going to graph those points or try to represent those points exactly. We're going to do a really rough sketch. If you scale the axes or just label the axes here, what goes on the horizontal axis there? That's supposed to be the independent variable, so that should be house size, and that's in square feet. Then the dependent variable on the vertical axis, that's gallons of paint that we're going to need. And we know this is increasing, right? This is actually a linear function, so it's increasing this way. I'm not going to label anything. I'm not going to try to plot points, but just a rough sketch, that's our function. F of S equals S over 250. And the output, that tells us how many gallons of paint we're going to need. So we've got our exact formula. We've got the table. We've got the graph. That's good enough for this one. Let's go to the last example here. Example 4. We're going to look at it from a different perspective to start out. I'm going to give you the graph. So given a graph of F, let's plot some really basic points on here. Start with some axes here. 5, 10, 15, 20 on the x-axis. And I'm going to put some points down, namely 0, 0, 5, 20, 10, 0, and 15, 20. And I just make this nice rough wave through there. So really basic sketch, really rough sketch. Only 4 big points that I put down. Everything else, again, just a nice wave going through there. That's our function F. Don't know what the formula is. All I know is I have this graph of it. So we're certainly used to writing and seeing points on a graph as just being x, y. But I want to remind you that in pre-calc, we don't typically use the y there. We'll say x f of x. So your output, where y typically is, we call that f of x. So I want to ask you a couple questions about this graph. The first one, part A, what would f of 5 be? So remember, this is where x typically is, so if it's usually f of x, you plug in 5 for x, I'm asking you what the output would be. So if the x is 5, the output, if I can map that up there, how high is it? That's at 20. So if my input's at 5, I can make a dotted line up here. My output, my answer here is 20. Okay, and then part B, what's f of 10? So that one's actually right on the horizontal axis there. So if the input's 10, the x is 10, the output, the height, is just 0. Nothing to really map out. It's right on the line there. Part C, f of what number, what value gives you 0? And just as a reminder, we are used to seeing it like this. F of x equals y. So you plug in the input, your answer is the output y. So this question is about the input. What input, what x value gives you an output of 0 or a height of 0? So think about that for a second. Which x values give you an output of 0? Graphically, a height of 0, you should still be on the x-axis. So we kind of talked about the 10 being there, and it looks like there's another point too. There should be 2 answers. We have 0, 0 as a point, and 10, 0. So both 0 and 10 give you a height or an output of 0. So the answer for that one, the x values could be 0 or it could be 10. 2 answers there. A little bit different if I ask you about the inputs as opposed to the outputs, like in parts A and B. And the last one here for today, part D. F of what value, just put a little question mark there, f of what value equals 20? So I'm really looking for the input. what x value, what input here would give me an output of 20. And the outputs, those are our y's, right? So height of 20 on the graph. Well, we actually already know one of them. One of the inputs has to be 5. That gets you an output of 20. The other input, the only other place we have a 20 as a height, would be the 15 here. So I've got my input of 5, that's one answer. An input of 5 gets me to that output of 20. And also, if I use 15 as my input, let me try to dot this, go 15 as my input, my height, my output would be 20. So two answers for this one as well. We've got x equals 5 and x equals 15. Both have outputs of 20. All right, so we talked about functions. We talked about them as a rule. In words, we have a formula for a function. We can look at it through a table, or we can read it from a graph. And that's all for these notes. I'll see you in class.